Hello everyone. In this video lecture, let us discuss about the solution of algebraic and transcendental equations. So before going to the topic, let us see what is an algebraic equation and transcendental equations. Algebraic equations means an equation f of x equals to 0, where f of x equals to a naught x power n plus a1 x power n minus 1 plus so on an. Here a naught, a1 up to so on an are constants, are simply real numbers. So if a naught not equals to 0, then this polynomial or an equation is called the nth degree algebraic equation. For example, x cube plus x square plus 1 equals to 0. It is an algebraic equation of degree 3. In the similar manner, x power 4 minus x cube minus 2x square minus 6x minus 4 equals to 0. It is also an algebraic equation of degree 4. If this algebraic equation contains some other functions like trigonometry functions, logarithmic functions, exponential functions. Trigonometry function means sine, cos, tan, so on. Logarithmic function means log x, log 2x, log x to the base 10. So this type of logarithmic functions. X e power x equals to 2 is an example of transcendental equations. It is a transcendental equation because it contains some function, special function e power x, exponential function. So it is called the transcendental equation. In a similar manner, x sin x minus 1 equals to 0 is also an transcendental equation because it contains the term sin x trigonometry function in the equation. So we call it as transcendental equations. So in this topic or in this chapter, we find the solution for this type of equations, algebraic or transcendental equations. No problem whether it is higher degree, 5th degree, 6th degree, 7th degree, whatever it may be. Actually, in previous classes or previous studies, you find the roots for 2nd degree or 3rd degree. Mostly you will go for the 4th degree by synthetic division method or factorization method. But if the degree is raised more than 3 or 4, then it is not as simple as you do it by factorization method. We use numerical methods for this type of algebraic or transcendental equations. Numerical methods contains some methods like bisection method, method of false position, iteration method, Newton-Raphson method, Jacobi and Gauss-Seidel methods. So these are the some important methods in this numerical methods to find the algebraic and transcendental equation solutions. Actually, what is the solution for this type of equations? If I give you an equation like this, x square minus 2x plus 1 equals to 0, then no need to go about the numerical methods or any other methods. You simply will write it as x minus 1 whole square equals to 0. Then x equals to 1 comma 1. Here 1 is called the root of the equations, or it is called the solution of the equations. It is called the solution because if you substitute this 1 in the given equation x square minus 2x plus 1, then it satisfies, which means it gives the value of 0. 1 square 1 minus 2 plus 1, that is 0. It is called the solution of the equation. If I give you an equation like this, x square sin x minus 2 equals to 0, or x e power x plus 1 equals to 0, or x log x plus 5 equals to 0, then it is not such an easy to find the root for these equations by factorization method or this type of method or synthetic division method. So we use numerical methods only. So here there is a definition for root. Already I explained you what is a root, which means any number which satisfies the given equation is called the root. Satisfied means if you substitute that value in that equation, it will give the answer 0. So similarly, I will say that a real number alpha is called the real root of the equation f of x equals to 0 if and only if f of alpha equals to 0, then we call it as root. So in these methods, especially we have to discuss a fundamental theorem for the roots, that is this statement: let f of x equals to 0 be continuous in a closed interval a b. F of x equals to 0 be a function or a equation of a given curve. If it is continuous in the interval a b, if I substitute the value a in the equation f of x, that is f of a, it gives a negative value. So mathematically it can be shown as f of a less than 0. If I substitute the value b in the equation f of x, then we will get f of b, which if I get it as positive, that is f of b greater than 0, then this theorem states that there exists at least one root in between these two values a and b. So similar as it is written like this, then f of x equals to 0 will have at least one root between a and b. Here there is a geometrical representation here. If I take f of x equals to 0 by a curve, the curve equation is like this. F of x equals to 0, the curve equation is like this. If I substitute the value a in the given equation, then I got f of a. If I substitute b, then I got f of b. Then this curve will touch the x-axis at a certain point c, which is the root. It lies between the values a and b. This is the statement of fundamental theorem of roots. So now let us move into the main topic, bisection method. Bisection method. It is a simple method, simple iteration method to find the solution for algebraic or transcendental method. It is also called as Bolzano method or half interval method. In this method, we will find like this. We will consider an equation f of x equals to 0. Then previously said that we have to find the two real values such that one should be give the positive value and another should give the negative value, such that f of a less than 0, which gives the negative value for the function. Similarly, I will choose another real number which will give us a positive value for the function, that is f of b greater than 0. So that I will find the root in between these two things. By this bisection method, I will do the procedure like this. So I will choose the two values a and b, which leads that f of a less than 0 and f of b greater than 0. Then I will take average of these two values a and b. Average means a plus b divided by 2 gives you the average. So we will get a value x1. It is an average of these two values a and b. If I substitute this x1 in the given curve equation, f of x1 equals to 0, then x1 becomes the root of the equation. If f of x1 is not equals to 0, if I get some values, if it is negative value, f of x1 is negative value, then the root lies between the positive and negative. So if f of x1 is negative, then I will replace the value a by this x1. So the root lies between x1 and b. If it is positive, f of x1 is greater than 0, then I replace this x1 with the positive value b. So the root lies between a and x1. So I will continue this process, go on so up to the desired accuracy root will find, or simply until two successive approximations are approximately equal. So I want to explain like this. If I take an equation, I choose a value, negative value a, which gives f of a negative, and I choose a value b, which gives f of b positive. So by the fundamental theorem of roots, at least one root will be exist in these two values a and b. So by taking the average of these two values, a plus b by 2, I will get here x1 equals to a plus b by 2. x1. If I substitute this x1 in the given curve equation f of x1, if it is 0, then it is the actual root. If it is positive, then the root lies between a and this x1. If it is negative, then the root lies between positive and negative. So the root lies between b and x1. Suppose if it is positive, then the root lies between a and x1. So by again averaging, taking an average between a and x1, here we will get x2. So if I substitute this x2 in the given curve equation, if I got it positive, then the root lies between a and x2. If it is negative, then the curve lies between x2 and x1. So by continuing this process, the distance between a and b will be reduced, and we will get an accurate approximate value. So this is called the bisection method. Here I will show you in the curve equation. Here f of x, y equals to f of x be the given curve equation. I choose a value a such that f of a is negative. I choose another value b such that f of b is positive. F of b is positive. By taking these two equations, these two values a and b by a and b, by taking the average of these two values, then I get an x1 value here. So the root lies between a and b. By going on this process or going on this type of successive approximations, I will get x2 and then x3. To number of successive approximations are approximately equal, then I will stop. That is the required approximate root. I will show you through a problem. Here there is a problem like this. Find the real root of the equation x cube minus x minus 1 equals to 0 using bisection method. Here a curve equation is given x cube minus x minus 1. So in bisection method, already I told you we have to choose two real values such that we have to go it for trial and error method. So if I substitute 1 instead of x, I will get f of 1 equals to minus 1. 1 cube is 1, 1 minus 1 minus 1, that is minus 1, which is negative. So now I have to choose a positive value. So if I substitute 2 instead of x, then 2 cube is 8, 8 minus 2 is 6, 6 minus 1 is 5, then f of 2 is positive, 5 is positive. So by the theorem, I can say that the root lies between 1 and 2. So by bisection method, we have to take the average of these two, 1 and 2. So 1 plus 2 is by 2, 1 plus 2 is 3, 3 by 2 is 1.5. So I have to check whether 1.5 gives a positive value or a negative value or equals to 0. If 1.5 is substituted in the given curve equation, if I get 0, then it is an exact root. Or else, if I substitute like this 1.5 in the given curve equation, then we will get a 0.875, which is a positive value greater than 0. So the root lies between the negative and positive. The negative value is 1 and the positive value is 1.5. So the root lies between 1 and 1.5. Now again I take the average of these two, 1 and 1.5. So the average is 1.25. Now I have to check whether 1.25 gives you the positive or negative value. Substitute this 1.25 value in the given x cube minus x minus 1 equals to 0. So I will get minus 0.296 less than 0, which is a negative value. So the root lies between negative and positive. Here the negative value a1 is replaced by this 1.25, and already we have a positive value, that is 1.5. So the root lies between 1.25 and 1.5. Again I will take an average, 1.25 plus 1.5 by 2, that is 1.375. If I substitute these values in the given curve equation, I get 0.2246, which is a positive. By continuing this process, it will end somewhere. I will look for a repetition of two decimals after this point. If the two decimals are repeated, then I will stop. That is an approximate root. I will make it little bit easier by using the calculator. Here I will take the same example or same problem, but I want to do this by using a calculator and tabular form. Number of iterations, that means first iteration, second iteration, third iteration, so on, gone number. I will choose the values a, negative values here and positive values b. C is the root, which is the average of these two. So average means c equals to a plus b by 2. Then I will substitute this c value in the given function, that is f of c. So these values are taken in this. Okay. So let me explain through calculator. For better experience, while watching this video, take a calcium in your hand and do along with me. Your participation will give more presence in the problem. So I will clear the previous data in this calculator. So for clearing this type of calculator, we have to press shift and then 9. Here it will show that it is clear. We have to clear all the memory. So I will take 3. Again equal. So the previous memory, everything is erased. Now it is fresh. Now let us start. Here I will store x cube minus x minus 1 in this calculator. So I will store like this, alpha, here x. If you observe this calculator, the pink color numbers will be entered after pressing alpha only. So I press alpha and then here bracket button. So I get x alpha x here. So I will have to store that x cube minus x minus 1. Here I want to put x cube. So shift x square gives you x cube. Then minus alpha x minus 1. Here it is the given equation. To store this equation, press calc. Then it will ask what you will give you the input for x. Then I will give 1 for this. So if I substitute 1 in this equation, I will get a value minus 1. Again, calc. If I give x equals to 2 here, then 5. So my actual requirement is fulfilled here. I get two values. One is negative and another is positive. So the root lies between 1 and 2. So we can write it on the paper straightly by using this calc. Then I will store this c equals to a plus b by 2 for substitution of the given root. So I will take AC button. In the same process, I will store this alpha x, alpha calc. It gives you the equal, x equals to, then bracket, again a bracket, alpha a plus alpha b, bracket close, divided by. I store this formula in this way. X means the root. This a plus b by 2 value will be stored in this x. I can use this value in the x cube minus x minus 1. So that's why I choose like this, x equals to a plus b by 2. Again, calc. Here a is 1. Again, it will ask what is the value of b. I will give an input 2. So it will give 3 like 3 by 2. If I want it as in like this, press this button, then it will convert into points, 1.5. So C is 1.5. I have to check whether 1.5 is positive or negative. Then by clicking this button, up arrow button, I will get the previous expression x cube minus x minus 1. So giving calc, so it will automatically show you the previous value 1.5. No need to give the input. So if you substitute 1.5 in this equation, what you will get? 80.875, which is positive. So the root lies between the negative and positive. Negative is same 1. Instead of 2, I have to write 1.5. So the root lies between 1 and 1.5. Again, I have to take the average of 1 and 1.5. So again, I will take that formula, x equals to a plus b divided by 2. Again, calc. Here a is 1. Same. I have to change the b value. That is, instead of 2, I want to write 1.5. Then it is 1.25. Now I have to check this 1.25 whether it is positive or negative. Again, press up arrow button. You have x cube minus x minus 1. So press calc. 1.25 is our previous value. So press equal. We will get the value minus 0.29685. So for our convenience, I didn't write all these things. Just I adjusted to 3 decimals, up to 3 decimals. So minus 0.29685. Mostly give value only for the sign only. Don't bother about these values. Just we are checking whether it is positive or negative. So it is negative value. So I want to replace negative a by 1.25. Positive is same 1.5. So the root lies between 1.25 and 1.5. Now I have to take the average of these two things. So press up arrow button. You will get this formula. Press calci. Now it will ask what is the value of A. Now I will change here. That is 1.25. Then B is same 1.5. Then it will calculate. It will give you a fraction. So to convert it into the points decimals, then press SD. So 1.375 is our C value. Now we have to check the 1.37 value gives you positive or negative. Go for that formula x cube minus x minus 1 cal C. You will get the previous value 1.375. Click equal 0.2246. So it is a positive value. Positive value means we have to change B by 1.5 by 1.375. So negative value is same 1.25. Then we have to change B by 1.375. Now we have to take an average of these two things. Can see A is 1.25 is same. B instead of 1.5, we will 1.375 equal 1.3125. Then check the value. Calcium 1.3125 equal minus 0.0151, so on, which is a negative value. So I have to change 1.25 to 1.3125. Now I will write 1.3125 here in A and 1.375 in B. So I will take again the average between these two things. Calcium A is 1.3125. Then B is 1.375. Then we will get an average 1.34375. Now we will check whether it is positive or negative. X equals to 1.34375 given equals 0. It is positive. So I have to replace B 1.375 by 1.3437. The root lies between 1.3125. Like this we will go on up to here. I will take 1.3242. That is minus 0.0022. I will stop here. Why? Because 1.32 is repeating here. Just I will take the repetition up to 2 decimals. Here you observe that 1.32, 1.32, 1.32. So the approximate root is 1.3242. Okay. We will move on to the next. Before going to the next problem, let us clear this. Shift clear 3 equal. While watching this video, if you have a calculator, keep it within your hand and do along with me. So what I am doing, do along with me. Then you will get a better experience. So if you have any doubt, just pause the video and go through once. Okay. We will move on to the next problem.